Hello, and welcome to G Fun Facts Online. Imagine a force of nature so powerful it can toss cars like toys and peel the roof off a building like a tin can. We're talking about hurricanes. As these storms get stronger, you might think the only answer is to build bigger, thicker walls. But what if the smartest way to fight the wind isn't to fight it at all? What if we could use an invisible ally to tame the storm? Today, we're diving into the incredible science of aerodynamics and how it's creating a new generation of hurricane-proof buildings. The cost of these storms is staggering. In 2017 alone, hurricanes Harvey, Irma, and Maria caused over $300 billion in damage in the US. But beyond the money, there's the human cost of losing homes and entire communities. In response, a quiet revolution is happening in architecture, and it's all about cheating the wind. So, how do you make a building invisible to a hurricane? At its core, it's about minimizing wind load. Think about a traditional, boxy house. It's full of flat surfaces and sharp corners. When a hurricane hits, these features act like a giant sail, catching the wind and allowing immense pressure to build up until something breaks. The solution is to think more like a car designer or an aircraft engineer. You need to create shapes that let the wind flow smoothly around the structure instead of pushing against it. One of the most effective strategies is to get rid of corners. Buildings with curved or circular shapes are naturally more aerodynamic. With no flat surfaces to push on, the wind simply slips around them, reducing the pressure by as much as 30%. Another huge vulnerability is the roof. A traditional A-frame roof can act just like an airplane wing, creating uplift that can literally tear the roof from the building. The aerodynamic solution is a hip roof, which has slopes on all four sides. This design, especially with a gentle pitch of around 30 degrees, helps deflect the wind and keeps the roof firmly in place. These principles aren't just theories. They're already being used in incredible structures around the world. In China's typhoon-prone Sanya region, a resort shaped like a mangrove tree uses its unique form to slice through the wind. Even the world's tallest building, the Burj Khalifa in Dubai, uses aerodynamics. Its tapering, multifaceted shape is designed to disrupt and confuse the wind, preventing powerful vortexes from forming and shaking the tower. But shape is only part of the puzzle. You also need the right materials. This means using impact-resistant windows made of laminated glass that can withstand flying debris. Why is this so important? Because if a single window breaks, the wind rushes inside, pressurizing the building from within and creating explosive forces that can blow the walls and roof apart. This aerodynamic design must be paired with a strong skeleton. This is where reinforced concrete, steel, and special metal ties called hurricane straps come in. These straps create a continuous load path, locking the roof to the walls and the walls to the foundation, turning the entire building into one unified wind-resistant structure. Now, what about coastal areas, where buildings are often elevated on stilts to protect against flooding? This solves one problem but creates another. The space underneath the building can become a wind tunnel, accelerating the air and creating intense pressure on the floor above. Engineers have a clever solution for this: breakaway walls. These are non-structural walls on the ground level designed to collapse under the force of water, allowing the storm surge to pass through without taking the whole house with it. The future of this field is even more exciting. Researchers are using artificial intelligence to run complex simulations and create more accurate wind maps, improving building codes for everyone. And at facilities like the Wall of Wind at Florida International University, engineers can blast full-scale test houses with 150-mile-per-hour winds to see what works and what doesn't. As our climate continues to change, we're learning that the key to survival isn't just brute strength, but elegant, intelligent design. By harnessing the power of aerodynamics, we're not just building structures that can withstand a storm, we're building resilient communities that can recover faster and face the future with confidence. Thanks for listening to G Fun Facts Online.